Hello, welcome to another episode of Let's Make It. This is episode number 63, and today is the 23rd of June. So we're recording this at 9 p.m. on Monday, like we do almost every week at 9:30 on Monday. And this week's going to be a lot of pre-recorded video. So our main thing we're going to talk about this week is EagleCAD, and I'm going to do two segments, one this week and one next week on EagleCAD. This week we're going to actually walk through creating a schematic, and I'm going to take an old schematic that I did in a different piece of software that I no longer like to use and convert it to EagleCAD. So you're going to watch me do it live, and the reason I pre-recorded it instead of doing it live right here is because I wanted to fast forward through a few things, because it gets kind of tedious as I start duplicating the work. So I kind of fast forward to make the segment a little shorter, and it's already very long. So we'll get into that in a few minutes. A few things before we get started, though. I do want to appreciate everybody. I do appreciate really everybody spreading the word. It's been growing, and that's a good thing. So I like to thank everybody every week for telling your friends and spreading it around. We're getting more and more downloads. The Roku app's just downloading like crazy, and it's growing quick that way as well. So all good on that side. Also, if you're buying things on Amazon, definitely appreciate that. And if you're not know what I'm talking about, if you go to our website, there's a link, a little banner at the top. You click on that, and you can buy anything. You can buy, electronic toys or household items, whatever you normally buy on Amazon, using that link, and we just get a little bit of percentage from it. You don't cost anything extra for you. It's the same for you. It just helps us to get things to grow on our side. So we definitely appreciate that. And all of our shows are available on Roku, and you can get us on the podcast directories. We're on YouTube. You can go to the TechZen TV website. You can pretty much connect with us many different ways. Just search for tech-zen.tv, and you'll find us. All right, so a few things. This week I said we're going to talk about doing the schematics, and then next week we're going to talk about actually designing the boards. And when we're done with this segment today in the show notes, I'll actually put a PDF of what I did this week. But next week I'll put the whole Eagle file in there, so you can download, if you want to download the free trial of Eagle and play with it, you have it. And I'm going to put a few other boards. So we're going to put some of our button boards out there, and some of our breakout boards that we use inside of our boxes. That way you can look and see and play with Eagle and kind of get a feel of what all it can do. Because it's kind of daunting when you first get into it. I've been doing it probably about 6 months now. I've converted almost all of the drawings from my old systems up to Eagle. I still have 3 or 4. This one that I did for this segment was actually one that I haven't done yet. So that's why I picked that one. But I'll give you a couple other ones next week, and you can pull down and play with the board designs. You can redesign your own boards with the schematics and move the schematics around, things like that. For this week, I'll just give you the PDF of what I created out in the show notes. So before we go too much farther, I'm going to go ahead and start the segment. Like I said, the segment's a little long. It's probably like 45 to 50 minutes. I didn't time it. So, but we'll come back afterwards and we'll talk a little bit about that. So let's go do that right now. And PC boards. I've been using this, I don't know, probably 6 months or so. I have used many things in the past, and this is the best thing that I've ever used. You remember early last year, we showed you fritzing, which is what I have on the screen right now. And I'm actually going to recreate this. This is something that we did early last year when we were teaching about the MCP 23017 I2C GPIO chip. So this is a board we created. You can buy it in the store. I think it's still in the store. But after I'm done this drawing, I'm going to recreate it and put this board up. The new board I'm going to create up instead. There's lots of things about it that fritzing does okay, and it's free. Fritzing is free. Or Eagle's not free, but you can get Eagle for $69 for the hobbyist. And as long as you're not making money on the stuff, you can use Eagle. We have now purchased the full version of Eagle that we have. But what I want to do is recreate this. You see all these lines. So you see these blue lines going over here, and it looks like a wiring diagram. But this is very confusing. And you see, Fritzing doesn't do a great job making things square and pretty and that really that really bothers me. And it's an okay design software, but Eagle is just so much better. So we're going to recreate this in Eagle, and we're going to show you the difference in it. It's going to be a couple segments. The first segment I'm going to walk through, I'm going to recreate the schematic. I'm going to recreate this right here. I printed this out and I have it sitting next to me. So I'm going to go ahead and recreate this whole thing in Eagle. And through parts of this recording, I'm going to go ahead and fast forward through things because it's kind of redundant. I'm going to explain to you what I'm doing, then I'll fast forward through it and you can watch me do it. And then I'll come back and I'll explain, and we'll talk a little bit more after that. But when we're done, we will be able to see what the next segment is, where we actually lay out the PC board itself. But in this segment, we're going to talk about basic schematic diagramming, a little bit about Eagle. I mean, you can't really get Eagle until you use it, because there's little things it does a little differently than some programs. But I'll try to explain them as I go along. But if I miss something, the best way to learn is just to download a copy of it and try it. I think there's a trial period. I'll have to check, and when I do the show, I'll let you know what the trial period is, if there is one, to try, because it's great software. I'm converting everything from I have my diagrams or schematics in 3 different programs, and I'm converting everything over to Eagle as time goes on. So anyways, without wasting more time, flap my lips, we're just going to go through this drawing real quick to show you what we're going to put in. This chip right here is the 23017. So right here, MCP 23017. We did a whole show on using the 23017 as a general purpose I/O for our expansion on the Arduino. And I can't remember what the episode was, but you can go back through the history and look at that. That was early last year sometime. And then we have our LEDs right here. And these are actually resistor arrays. So that's one of the things about fritzing, is it's not very easy to do things that aren't already in this library over here. And that's something that's really easy to do in Eagle. And then, of course, we have the Arduino on this side. We have buttons here for the input, like we're using the LEDs for the output. And this is actually a great board to learn I2C and GPIO. That's kind of what we created for, is mainly for ourselves to figure out the 23017 worked. And actually, we do use this chip now in a few other designs outside of the stuff here on Let's Make It. And then we'll talk about the RGB over here as well. And we're going to rebuild this. So kind of keep this in your mind. We'll come back and look at it when we're done. And we'll kind of compare the 2 different schematics. So let's go ahead and we're going to hide this. All right, so what you see here is what you see in Eagle when you first start. It looks a little bit daunting because it doesn't really tell you what to do. But this is what the control panel looks like. And if you have projects created, you can come in here and you can see projects. I don't generally do them under projects. I just do them as individual files and put them in folders. I've never really adopted the projects thing. The cam jobs are what you can use to actually generate your output. Here's a Gerber output. We actually have our own that we created for the company that we use. We went back and forth a few times and actually developed a cam job with them. So I have one that I have stored outside of Eagle that I use considerably frequently, actually, especially here recently. And then you can do some scripts, some user language programs. But where I really want to get into here is the libraries. One of the things you will find in Eagle is there is an almost unlimited number of libraries for almost anything you can think of. Most manufacturers of electronics have created a library for Eagle. It is like the standard for doing design. So if we scroll down through here, you can see these are all of the libraries. Now, the library has tons and tons of things in it separately. So you can just see this is what I am using as far as a library goes. But let's just do one real quick here. Let's look at Adafruit, for example. This is one of my favorite libraries. She has lots and lots of stuff in the library. In fact, we're going to use it a lot today. You can see inside of her library, she has all this stuff inside of her library. So much more choice than what you get in fritzing. It's almost unlimited, and you can make your own. The libraries are very easy to create. We have some parts that are actually our parts that we developed that are in a library that we created. So we've got an experience now doing that. And it was actually much simpler than what I thought. It was a little bit confusing at first, but after I figured it out, it's really quick to go in. And if you find somebody else's library that maybe you don't want the ICSP pins on your Arduino to be wired up, or you want to use that space for something else, you can go in and copy it and modify it and make a different variation of it using the same basic library what you already have. But you see, I'm still inside of a Adafruit library here and scrolling down. So there's the end of the Adafruit library. So it's huge. But besides the niceties of the libraries and everything, all we want to do right now is we're going to create a new schematic. So to do that, it's very simple. You go to File, and you go to New, and you say Schematic, just like that. And we come up with a blank sheet. Now I'm going to try to size this for the screen that I have recording here. It always opens up really small, too small for a work area. All right, let me see. I got it. Kind of got a monitor off to my side here that I'm watching to see if I'm going off the screen or not. And that looks good right there. All right, so here is our blank canvas that we're going to start from. And I want you to notice one thing right here. This little plus or crosshair right here is the bottom left side of your drawing. You don't have to follow that, but you're going to want to follow that, mainly because you make it a habit. Because when you get into design the PC board side, it's very important that you use this, because that's where your PC board size starts and goes this way and goes this way. All right, so the first thing we need to do is add parts. So we're going to go to that library I just talked about, and we're going to start adding parts. So I know where some of these parts are, but we can also search for them. We're going to come in here, though, and go ahead and click on right here. This little thing right here next to the delete is add part. And when you hover on this, it says add, and down at the bottom in the status bar, it says add a part. So we're going to do that. And what's going to happen is it's going to load up the libraries. So I know the first thing that I want is an Arduino, and Element 14 has a great library for Arduinos. It's probably the one I use the most. And we're going to come down here, and we're going to take the Uno, and I actually have some of my own versions of the Uno from them that I've modified slightly just to move some of the pins around where they connect up here. So, but what you see when you click on that is you see a couple things. This is actually considered a package. So here is what it looks like in the schematic, this Arduino Uno image. That's where we're going to connect all our pins to, and this is what it's going to look like in the design area. And when you design the libraries, let me go over here. Example, here's the same Arduino with a different no holes thing right here. So you see what changes on the right. See the drill holes are here, and when you go to no holes, it's there, but this change stayed the same. So basically this is a different package, and I'm going to demonstrate this package concept when we get done with the schematic. I'm actually going to change our MCP 23017 to a different package, and so you can see live what it does without me making any changes to any wires. So it's one of the cool things also about it. But I'm going to pick the one that has the holes in it just for fun. So I'm going to double click on this, and at this point you'll see me carrying around on the screen an Arduino Uno. So I'm just going to place it by clicking, and if I want to place more than one, I can just click again and it would place it on the screen. But I only need one, so I'm going to stop. Next thing we're going to do is we're going to go look for the 23017. And now here's where I know Adafruit has a 23017 in it. That's probably the one I probably use most of the time. So we're going to come down here and we're going to scroll down, and here is the 23017, MCP 23017. I could also come down here and search if I wanted to. So here we're going to get into the package concept. We see our general layout right here of the schematic, but as I click on these, you're going to see different packages. So this is a 6x6 package. I think they call it, I don't know what they call this now, QFN or something like that. QFN, what does it say right here? Yeah, QFN 28. But we don't want to do that one. We want to come down, and here's a surface mount one. Then we come down here. Here's a through hole. Here's another through hole with round pins versus the oblong ones. And then we have the SSOP 28. Now we use SSOP 28s all the time with this, as well as the through holes. In fact, the original board that we did with Fritzing was a through hole design. But for this one, we're actually going to do it surface mount, because I think it's kind of a cool way of doing it. Save some space, and I'm also going to give you a good demonstration of some board layout and swapping parts back and forth. So we're going to click on this, and I just need one of these. So we're going to place one of these. And we're going to go back in the library. We can hit escape, or we can click on the library, either way. And we're going back into the library. And I need switches. I need tactile switches. And now while I'm in here, I know she has some of these in here as well. So we're going to come down here and single pull, single throw, tactical switch. So that's what it's going to look like. See, she has two different kinds. This is the kind that actually I know I have here. So I'm going to double click on this. And if you remember the old drawing, okay, this error just came up right here. We're going to talk about that in a second. we're going to show you what that is after I place my buttons. So I need a total of 10 buttons. I have 8 buttons for the GPIO, 1 button for reset, and 1 just a general purpose button that goes directly to the Arduino. So we're going to put in 10 buttons. 3, 4, 5, 6, 7, 8, 9, and 10. Don't worry about where they are right now. We're going to rearrange it here shortly. Now the error you saw come up there is because I haven't saved this yet, and I don't know why this happens. It's happening to me. But I'm going to go ahead and I'm going to save this real quick, and we're going to call it. I'm going to put it on the desktop, and we're going to call this tally test 4. All right, so now we see that the error won't come up again. All right, let's see what else we need. We need 8 LEDs. So we're going to go back over here to the library, and we're just going to pick out a basic LED. And again, I'm just going to pull one out of her library. I think she has some here, LEDs. And I'm going to do surface mount LEDs. So I'm going to do 0805s. I have 0603s and 0805s, but if I'm the one putting the chip on the board, 0603s are just a tiny bit small for me. So I'm going to pick on the 0805s. There we go. So I need some of these. And I need 8 of these. So I'm just going to plop them on the board here. Like I said, we're going to deal with where they're going to go later. I'm just trying to populate it. So there's 8 LEDs. I need some resistors. So let's say, I don't know if she has any basic resistors in here. Now let's go look. I don't see anything generic from her. Let me go up top and see. Maybe something up here. I do not see anything. Let me, I'm going to search. I know I want 0805 resistors as well, so I'm just going to search for 0805 down at the bottom. And you see I have a bunch of resistors now. Now this is Deshay. They basically have one for every part number they have. So if you click on this, over here you're going to see what it is. This actually is valued at 1.21K. It gives you the part number and everything. I may end up actually using one of these just as a generic, but let's keep seeing what we have in here. You can see they have a lot of resistors in here. So if you know the part number for resistor, from them you can probably find it. But I just want a generic 0805. Yeah, so they're all pretty much the same. So I'm just going to grab one. It doesn't matter what the value is. And see how many of these I need. I need 1, 2, 3, 4, 5. It looks like. So I need one for the I2C for pulling up or biasing it towards positive for STA. So STA, SCL. I have an RGB LED, so I'm going to need 3 of those as well. I think that's all I need. All right, so I do need a resistor array as well. So I'm going to go do a resistor array. And actually, let's look for a resistor. And we'll see if we can find a resistor array. I think I saw one towards the bottom of the... Can you hear my mouse scrolling away? Because this is so big. Let me just yank this to the bottom. I'm pretty sure what I saw was down here towards the bottom. Resistor network. Let's see, 8. All right, that's the wrong format. I'd like to have a resistor network that's not a through hole, and unfortunately, it's the only one they have for that. Let me see. Here's a 16 by 8. So this is a little different than what our current resistor. Our current resistor has one input, or one pin goes to ground or positive or wherever, and then 8 outputs. But this is going to accomplish the same thing. It's going to be a little bit more wiring, but in the end, it's actually not that much more. So we're going to use this, and we need 2 of these. So I'm going to plop them down here. And let's see, I need an RGB LED yet. So let me come back over here, and we're going to search for RGB and see what we get. Spark Fun. Common anode or common cathode? I want common cathode, I believe. I mean, here's the drawing. Let me show what it was. Yeah, it's common cathode. So here's where This is a through hole, so I'm going to do one thing with through hole here. I don't have any tricolor LEDs that are not through holes, so just for our purposes here. So there's, look the same to me. All right, so we have one. All right, so we're done putting parts. So now we should have all of our parts. Let me just make sure I have everything. Go through the drawing here. Resistors, 2 push button. I think we're good. All right, so now what I'm going to do is I'm going to kind of zoom out. Oh, there's one more thing that's and it's not necessarily a requirement, but I like to have it, and it's called a frame. And let me get rid of this. And I know it's under the frame. I like frames just because it makes things nice and neat. You can document things, and you can tell the edges of stuff. So it's just a personal thing, but we're going to use an 8.5 by 11 frame, just like that. So I'm going to select it. Oops, where'd it go? Frame 8.5 by 11, and I'm going to put it right on the hash or the crosshair thingy right here on the document. It's at the bottom left, and now I have a frame. All right, so now we're good to go. Let's kind of bring the whole thing into view here, and we're going to rearrange things a little bit. So I'm going to first of all move the Arduino, just like so, and I'm going to turn it around so it looks more like you're looking at the Arduino. And the way that I'm doing this, I should probably explain that too, is over here on the left, this is the move, and in fact if you hover on it, it says move, and down in the bar at the bottom it says move an object. If you click on the crosshair, everything has a crosshair in it, and that's how you select it. So for example, in the case of the Uno, let me turn on my zoom clock. I click on this, and I click on the plus like that, and I have it selected, so now I can move it around. If I right click, I'm turning it. You can also, if you just want to turn stuff, you can come up here and use this right here to turn it around as well. And the scrolling in and out is done by the mouse scroll wheel. I just locked my scroll wheel because it was in free flowing mode, so now I locked it so I don't touch it by accident. Also want to take our general purpose IO and going to move it up here like this as well, very similarly. And let's kind of scroll out. This button right here, basically next to the scroll in, zoom in and zoom out, will center it. So I want to create two sections, input and an output. So I'm going to add some text. So I'm going to go here to text. And before I do this, I want to explain one other thing. Eagle has the concept of layers. So if you're familiar with Photoshop with layers, you'll be able to grasp this concept real quickly. This is layers right here. Now in the schematic, the layers don't mean as much as they will when we get over to doing the actual PC board layout, because there it's very important. Here you have basically nets, and then you also have the documentation, the gray stuff's documentation. So I generally put documentation and stuff under info, but your wiring has to be under nets. But you're going to see me move things around, and you're going to see me go back and forth. So I want to make sure I explain that. So we're going to click on T for text, and it's going to ask what the text is, and I am going to call the first one input, just like this. And one of the things you're going to notice right here is it says it's going to nets. I don't want it to be a wire, so I'm going to change this to info, and then I'm going to place the word input right here, and then I'm going to hit escape, and I'm going to do one for output. When you hit escape, it goes back one. If you hit it twice, it exits out. So we're going to do output, and we're going to put it right here, just like that. Now it's awful small, so what I'm going to do is I'm going to go to this I, which is info. It's how you look up properties of something. And I'm going to change first of all, I'm going to change the font to fixed. I'm a fixed font person when it comes to drawings. So, and I'm going to make its size 1.15 versus the 0.07. So there you see it's a little bit bigger, a little bit easier to read. And I'm going to do the same thing with this one. So this is going to be fixed, and it's going to be 1.15, just like so. Oops, something didn't work out. One up, one more. 1.15. There we go. Okay, so now we have our sections. Now I need to start moving my stuff around, and we're going to move things in groups. So let's look at one button first. We're just going to move one button, and you see it's kind of turned sideways. That's fine if you like the button to do sideways. I like it to be a push button to be pushed down, so I'm just going to flip it around 3 times, and there we go. So that's switch 10. But what I can do is if I want to move a group of things, I make sure I'm in the move. And this works for everything, not just move. You click in this area right here, define a group, and you drag around the group, just like that. And if you right click on this, you now can select move group right here. So we do that, and we can move the whole group around. Now, while you can move the group around, you can also turn the whole group. So now I have all my switches turned to the right direction. So let's kind of zoom in here to this area. And one thing about Eagle is wherever your mouse is and you zoom in, it'll zoom in, as that spot will always stay on the screen. So I've got a little bit of a mess going here. Let me scroll up so you can see where the word input is. And I want to grab my first switch, and I'm going to use this as an example. So you can't really see where switch 1 is, I don't believe. Switch 3, switch 4, 5. But let's say I click on one of these and it's the wrong one. I don't want switch 6. I can right click and I kept it automatically. So let me try to do a better demonstration of this. No. All right, I'll do that a little bit later. When I put the wires in, it'll be a little easier probably. So let me go ahead and kind of clear things out slightly so I can see what numbers are where. 7. Okay, here's switch 1. So we're going to put switch 1 right there. And then we're going to look for switch 2 right there. And you see these wires are coming up here. I don't know why it's doing that, but I don't want those. I will go through and get rid of them. And the way you get rid of them, I'll show you here in a second. Here's switch 3. As you come over here to this X, this is delete. And you click on the line, just like that. Alright, so there's switch 3. Let's see, switch 4 is right here. And switch 5. Switch 6. Switch 7. And switch 8. Let me scroll down a little bit here. And we have switch 9. And we have switch 10. Oh, no, switch 9 doesn't go there. Switch 9 goes over here. It's going to be a reset or something. We'll have to figure that out later, which one's going to be which. So we need to get those over here. Let me kind of get them up out of the way. I'll put them up here. All right, so our switches are kind of placed. And let's do the same thing with the LEDs now. So we're going to zoom in. Let's move this one out of the way. All right, so we have our LEDs, and they're all turned sideways, which is fine. That's perfectly fine. In my case, I don't want to do it that way. I want to flip them around, so I'm going to grab them like this, and I'm going to move the group, and I'm going to flip them while I'm moving them, and get them a little closer where they belong. Let's kind of scroll up here, and we're going to place them real quick. So I'm going to do LED 1, and then LED 2. And 3. And you see I can kind of line to the buttons just to keep them kind of visually the same. You wouldn't have to do that. It's totally up to you. I'm just like things being a little bit visually similar. 5, 6, 7, 8. So there are our buttons. So I have them all aligned to the tops. I believe so. All right, so our buttons are kind of the right place, although I think they're a little close to the input, so I'm going to go ahead and move. I'm going to move actually both of them. So I'm going to do a group move. The switches should be a little bit more, I would say, centered to the word input. Well, I like where input's at, so I'm just going to kind of move them a little bit like that, and that gives me more space for the output. So I'll leave the output where it's at. All right, let's figure out what else I got to place here. I have to place a reset switch, which is already here. So I'm just going to basically, what I sometimes just do is just copy the text because it's already the right size and everything, and just click on the copy, and then we're going to place this, and we're going to go rename it. This is going to be our reset switch. And then I have a general push button, so I'm just going to call it push button. Again, I'm going to click here where it says copy an object. I'm going to click on reset and just drag that over. And I'm going to move down a little bit, although I don't have nothing going in there. I still like to keep a little bit farther away. And this is just push button. That's what I'm going to do. Push button, just like so. All right, so that makes me need to move everything else around a little bit to make things line up a little neater. So it's too far. That's good. And reset. And then I have my LED right here. My 3 color LED, the RGB, and it's going to have some resistors. So I'm just going to kind of line them up here as well, and we'll clean this stuff up later. I'm just trying to place everything right now. And like that. And then these are going to be for the I2C. And then we have our 2 resistor arrays. And each of these input and output have a resistor array. I'm going to put them right here. Just like that. And I think we're pretty much laid out. So now we can get started creating the actual connections. So I could very easily take and do, I'm going to do this, I'm going to undo it then. Let me come up here and we're going to say that this is LED 1. So I could run a wire just like this. And it'd be similar first thing. Now the one thing I mentioned before about layers, see how it's gray? It should be green. So that tells me I did it wrong. So let me go here. I'm going to delete it now. So I'm going to go through here. I'm going to delete this because it should be in nets. So we're going to come in here and we're going to change our layer, run wire again. Right here's wire to nets. And I'm going to run the same wire. Just like that. And that would work perfectly fine. I could do that for all these LEDs and run all these wires to all these LEDs. What you'd have in the very end is what we have in fritzing, which is wires running everywhere. It makes it confusing. This is where Eagle has something that is awesome. So we're going to go through, I'm going to delete my runs. So we don't have this. And I'm going to add a small wire to this side of the LED, just like this, and one on this side. And then I'm going to add a small wire right here, just like that. And you can now name these, and they basically make a bus. So here's what we do. We come here and we click on name right here, define name for an object. And we're going to call this one LED1. And we're going to call this one LED1. Now watch what happens whenever I do OK on this one. It is asking if I want to connect them together. I'm going to say yes, I do. So now what's happened is I have this one and this one connecting, even though that they aren't physically connected via the drawing. And I'm going to name these. So I'm going to come out here and click on label. They're already named. I'm going to label them, I should say. And that is LED1. And that is LED1. So these are connected. I could make this LED1, and these all 3 would then be connected. So what I'm going to do real quick is I'm going to go through and do the LEDs, and I'll put it in fast forward through this because it's very much a lot of redundant work here. I don't need to, keep you guys tied up while I go through and do all this redundant work. So I'll just fast forward through this section. Okay, so I just did these. I'm going to clean up this again. This is a little bit of me being just a little crazy about the design. So I've labeled all the LEDs. Now I haven't finished over here on the 23017. So let me go ahead and we'll walk through here again. So basically I'm putting a small wire just like that. So I click, and then when I'm done where the wire is, I just double click. Double click basically says the wire ends here. If you don't double click, and you click once, it'll keep running like this. See how it's running like that? Or you can escape and it'll it'll quit. So basically I'm just putting in a small wire just like this, and then I'm going to come over here and there's this little button that says name, define the name of an object. So I'm going to click on that, and this is going to be LED number 2. And since I already have the LED 2 created right here, when I press enter, it's going to make sure I want to do that, connect them. And then I'm going to do LED 3, and then LED 4, and then LED 5. What is that? 5's right here. That's you see I have the wrong one highlighted. So let me show this to you. This is where I said before, I selected this one, but if this is the wrong one, like if you're in a busy area, if I right click, you see it picks the next one closest, and I right click again, it goes to that one because it's close, and again it goes to that one. So at this point I have to click on it because it's highlighted again. So this is LED 5, and then we have LED 6. Those little things like that you tend to learn the more you use it. It's a little hard to teach all that stuff in a short segment like this. Alright, so I've named all the LED pins, and then I come down here and there's this little thing right here, and it says basically if I hover on it, it's going to say that you can put a label on it. That's what this ABC thing is. So I'm going to click on the line. That's what I want, so click it again, and then there is LED 2, LED 3. Oops, I didn't want to do that. I got to move that, so I come back over here and do move, and select again, LED 3. Alright, let's come back down here for label, LED 4, and it's acting funny all of a sudden. I think it's because I'm doing a screen record. And come back over here. There it works. There it worked normal. It should move around like that. LED 7, LED. Oops, I moved it around again. All right, so there's our LEDs. These are all connected now to over here. But what we haven't finished yet is the resistor side. Now, in the fast forward, you may have seen me label these LED 8. Or 1 through 8, and then an R at the end for resistor. So I need to come down here, and I'll do this through fast forward too, but I'm going to go to this resistor right here and add in all the same thing I did here. One side goes to ground, and one side goes to the LEDs. So I'll do that in fast forward mode again. Okay, so there I did the resistor array. So the one thing I probably should have done in the beginning, and I haven't done this yet, and I'll go do that right now, is I haven't connected the ground or the 5 volts to either the Arduino or the 23017. So I'm going to do that. It doesn't matter what order you do it in. I mean, I generally try to do it just to remember it when I first do it. But so we're going to add 5 volts and ground to this. And on the Arduino, there's multiple grounds. I generally connect them all to ground. And then there's 5 volts right here. And there's also a ground on the ICSP, and there's also a ground over here. And I put them all to ground. So let me go ahead and name these really quick. So here we have ground, which is already a bus 4, so it's going to ask me. And then there's 5 volts, which I haven't done yet, so the first time I do it, it's not going to ask me for anything. But when I do 5 volts here, it's going to see there's another one and say don't want to connect them. So yes, and then we have our grounds. And we have our grounds. And a ground. There's lots of grounds over here. Ground. And a ground. All right, so let me go label these while I'm thinking about it. So we have our 5-volt pin there, have our ground pin there, 5 volts, ground, and I'm going to turn this one just like that, ground, and then we have ground. All right. So what we have done is our output sections are done. We have our LEDs connected to the MCP23017, and if we come back and scroll down here, we have the LEDs connected on the other side to a resistor array, which goes to ground. So now I'm going to go and I'm going to do the button side, and while I do the button side, I'm going to fast forward, as it's quite boring just watching me draw lines. But I'm going to be doing the exact same thing that I was just doing, where I'm going to name everything and label it. And then when I'm done doing that, I'm going to go ahead and do the resistor array as well. And when I'm done doing that, we'll come back and we'll see where we are. Okay, so I got the switches all connected up, and I'm going to make one other change here real quick, and this is again more cosmetic than anything. Is I don't like these being different distance than the ones on the right, so it literally is going to be something that simple. All right, so let's kind of scroll out here a little bit. We have our input and outputs connected. Well, no, we don't exactly. You notice these switches don't go anywhere. They're connecting to the resistor, but that's it. I haven't finished this side. So I'm going to kind of do that now, which should be pretty quick. And then we have just a few sections left, and then we'll be done. Let me go ahead and add these in here. And as you can tell so far, look how clean everything is so far. It's documented, or for the most part it's documented. I still have a few little things here and there, but we'll get in there and clean it up. So this is switch number 1. And we have switch 2, switch 3, switch 4, switch 5. And you can always come back and rename these too. Just because I'm going through doesn't mean I can't go back. If I make a mistake with one, it's no problem. As long as you haven't made the board, you're good to change everything. And you can always remake another one as well. Switch 8. Alright, so let me label these, and then we'll be done connecting our switches up. So our input section will be completely done. Alright, switches are all done. Let me save this. Alright, saved. Okay, so let's do the reset button. So we're going to do something very similar to reset. With the Arduino, you bring the reset down to ground to do a reset. So we're going to run a couple little pins here, just like this. And we're going to, we need to put one on the reset while we're here. So let's add one to reset. So we've added that to reset, and we're going to name, I'll name this side ground. And we're going to create a new bus called reset. So here we go. We're going to put reset. It doesn't exist yet, so I won't get anything for this one. But when I put this one in, it's going to ask me to if I want to connect it, and I do. So let's label these real quick. So we have ground here, just like that. Reset there, and we have reset up here. And let's see, we have our push button. Let's see, look at the drawing here and see where did push button go before. It went to D8. So we're going to do something very similar here too. We're going to go ahead and connect up wires like this. And I need D8. So we're going to run on the D8. And we're going to name these. This side's going to be ground. This side is going to be D8 for digital pin 8. That makes sense, right? D8 and D8, just like that. And we're going to label these. We already have our buttons connected. This is just the labeling process. All right, and D8. All right, so what's left here? All right, let's go down, and we haven't connected the I2C stuff yet. So let's do that. We're going to create an I2C bus for SCL and SDA. SCL, SDA, and we're going to name these I2C SCL, I2C SCL, and I2C SDA, and we'll do the same thing up here, I2C SCL. And it didn't ask me to connect, so something's not right. Something's not spelled right. It's not. There we go. It's ISC, I2C SCL. Good. And then I2C SDA. And we connected. So let's label these. And then we are connected. We still got to do one more thing with the I2C bus because we want to kind of bias the voltage high. Although it probably wouldn't matter as much on the current board because it's not really going anywhere. Alright, you see this is going to drive me nuts. This would work perfectly fine, but I have to rearrange the Arduino because these labels are off the thing. And I didn't get everything, so let me go back and do it again. I want to move. Group. Alright, that'll do it. Alright, so we have these two resistors down here and they are the wrong value, so I'm going to change the value. So to do that, I go to I for info, kind of like properties, if you're used to other things like properties. And this value is going to be a 1.5K. And we could say R1's fine. You can rename any part you want anytime. I generally go through afterwards and do that, but for our cases here, R1's just fine. And I need to change this one, 1.5K. Okay. And a couple things here. You see the stuff's overlapping. We're going to work on that after we're done with this. And we're going to, whoops, don't do that. We're just going to draw a line. And we bias I2C to 5 volts. So, like so. And we're going to name one side's 5 volts. And the other side is I2C SDA. I spelled it wrong again, didn't I? I2C SDA. There, I got it. And I2C SCL. I2C SCL. Alright, so let's label these. And then we're going to clean this up a little bit. It's called smashing, which I don't quite understand why they call it smashing. But you're going to smash these, and it's a little symbol right here, and it separates the name and value pair. So right now, if you move that around, they'll move together. If you do that, you saw the little plus handle things. Like this 1.5K doesn't have one. If I click here, it does have one now. So I don't need to know 1.5K twice. So what I'm going to do is actually delete this one right here. And it doesn't change anything. It just doesn't display the value. I think just one of these makes perfect sense. And then I'm going to take these and center them like so. So that makes it nice and neat. So what I want to do is also I want to label this. So I'm going to grab this and I'm just going to call it I2C bias. Or I'm going to call it I2C lift, I guess. I2C lift, because it's lifting to 5 volts. And I generally do everything uppercase if I can. Alright, so it's not quite centered. Alright, so the only thing we have left is, and this is not centered either, is this LED. And this is where, here I'm going to go, I'm going to smash this stuff first, because I'll change its values. These are going to be, we'll use 270 ohm resistors. Oops, that's the one I changed. Okay. 270 and 270. And it's just good to change these values because it does show up in the parts list. But I do not need all these, so I'm going to smash these as well. We're smashed there. We're going to actually get rid of 2 of these values just because it's in the way. And then we're going to move this. And I'm actually going to put it like this. And let's move this over so that it's aligned. All right. So now I'm actually going to run real wires this time, like I showed you in the very beginning. So let's go over here. We're going to run a wire, and we're going to run it from here to here, and from here to here, and here to here. So these are all connected. I want to run wires to these as well. And in this case, it's going to be, see, this goes to ground on this side. So I want to name this one ground, just like that. And then on this side, let's see, where's it go? It goes to D2, 3, and 4. So we're going to just name these D2, D2, D3, and D4. So that also means we need to run wires out of 2, 3, and 4. So we do this. We run 2, 3, and 4, and then we're going to name these. Here's D2, D3, D4. All right, so let's label these. D2, D3, D4, ground, D2, D3, D4. All right, let's add some text here. RGB LED. All right, and just to make things a little bit less crowded over here, let's move these 2 down just a little. Yeah, that's good. All right, so I think we are actually done with this segment now. So let's kind of review what we did. We've put all the parts in, connected them all via bus instead of running individual wires. And let me go show you the whole schematic. So there's the whole thing. And it's nice and labeled and very easy to follow. So let's again compare this to what we had before with fritzing. So we can go from this, what looks like a total mess, to this nicely documented schematic. That's the nice thing about Eagle. Plus, you can have multiple sheets. You can go here and you can add more sheets. So if your schematic is too big to fit on one page, you can have multiple sheets and they all work together just fine. Now, here's something I want to show you before we go for this segment, and then we'll be done. And then I know it's been a long segment. So I'm going to show you what it looks like on the PC board side now. So it's going to ask if I want to create one. I said yes. So I'm going to make it the same size, or almost the same size as what we currently have. So here's what it's done. This basically is our working area right here. See the crosshairs? This is our working area. You can define this bigger, smaller, or whatever. This is just a general working starting area. And you just drag the parts over here and place them where you want. So in this case, what I want to demonstrate over here, I'm not going to go into great detail, is I want to demonstrate part replacement. So we have put in this 23017 right there, and I'll kind of zoom in on it so we can see it is a surface mount chip currently. What I want to do is I'm going to come over here to the schematic, and I'm going to go to this replace button right here, and I'm going to go back up to Adafruit where I got that from. Let me turn off my scroll lock. There we go. Won't click no more. And I'm going to go down to the 23017 MCP 23017, and I'm going to pick the through hole just like that. So I'm going to double click on it, and I'm going to replace this chip right here by clicking on it just like that. I just replaced it. Let me go back and look at the schematic now, or look at the board. Look, it's no longer surface mount. It's changed. That is the cool thing about Eagle as well with the libraries. So I just converted it to a through-hole chip versus the surface mount chip that I had before. I'll go back and I'll put it back. So I'm going to come back over here. I'm going to go to replace again, and I want to go back to the SSOP 28. I double click. I replace the chip just like that. It's replaced, and I go back into the drawing, and we're back to the surface mount again. So that is a nice feature. I can convert this whole schematic into another board, a copy schematic, change the parts out as quick as I just did, and relay out the parts and have a through-hole board versus a surface mount board. Very cool stuff. So this is the end of this segment. We will go back to the show, and then we'll have the following segment. We're going to actually take that PC board and lay it out and make a PC board out of it. So we'll do that in the next segment. Thank you. Alright, so this segment is going to be teaching you a little bit about the EagleCAD or Eagle design software for creating schematics and PC boards. And I've been using this, I don't know, probably 6 months or so. Okay, so sorry about that rerun right there. That's a long segment, but actually EagleCAD is probably the best CAD software I've ever used before, and I've used quite a few of them, some on the PC and some on Linux as well, and I'm very happy with EagleCAD. Like I said, I only got a few more things to convert over. I actually converted the one over during these two segments. We'll do segment 2 next week, but since we've been doing this for we've been going 58 minutes now, I'm going to go ahead. I want to show you a few other things. I've mentioned before about some quadcopter stuff, so I got in some parts, and that's what's in these boxes here. This is an actual quadcopter, and I can't remember which brand this is. It was like $12 to buy this chassis. There's no motor or anything with it. I got the motor on the way here, but that's one of the chassis. And then I got a hexacopter chassis already as well. And then I got this other quadcopter, which looks like a DJI. It's not a DJI. It's a knockoff out of China. But here's the 4 sides to that. And then these centerpieces are actually kind of interesting because you can actually this is like basically a real thick PC board, and you can see solder points on there, so you can put your power and everything directly in these holes instead of running wires everywhere. So you basically solder your motor controllers or your speed controllers into this, and that's something we're going to be working on soon. I also got an open source control unit as well, and it's not hooked up yet. I just got it like Friday, I guess, and this is Monday. It's still in a little baggie, but that is parts are starting to come in. So like I said, I also have a DJI that I'm putting together. It's a hexacopter, so it's actually using the DJI Nazo controller. So we're going to be doing a couple different things with that, but the parts are starting to come in. So we got a few things coming up in the next couple of months here, segment-wise. It's going to be really fun. Next week, we're going to go ahead and finish the EagleCAD. I may have some quadcopter stuff put together depending on how things come on. And during the segment in the chat room, Jim asked about the B project, and actually you see sitting behind me a solar panel. Oops, almost knocked the TV off the wall. This solar panel is for the B project. So my bees are far enough away that I don't have power down there. So the simplest thing for me to do is to power them, power the sensors via solar. Now in my case, since I'm starting to build the sensors now, and for it to report back, I'm just going to basically take an Arduino for each beehive and a Raspberry Pi I'm going to use for the communication. So they're going to communicate to the Raspberry Pi through CAN bus, which I'm developing all the shields for CAN bus now. And they will basically I'm doing a shield for the Arduino that has sensor and CAN bus on, and then also doing a CAN bus shield for the Raspberry Pi. And that will allow them to communicate. Raspberry Pi will store it if it can't get to the network, although I should be able to get network from my house down to there. It isn't that far away with a decent antenna. So, but we're going to go through charge controllers and how to build a solar system as well, and during the Beehive project. So that's another segment we're going to do, is setting this is basically a 230 watt panel. It should be able to charge the battery nicely, and from what I can figure it out by my calculations, the battery that I got should last. I think I figured 2.5 days if I had to run two Arduino Unos and a Raspberry Pi. So, but that was not including any kind of wireless communication and stuff like that. So I could be a little underestimating it. So I have all the charge controllers. I got that stuff now. I got the battery. So we'll be working on that as another segment coming up. 2 weeks from now, I think I'm going to do a segment on creating libraries for the Arduino. So we've never really done a segment on creating libraries. And this past week, I was talking with somebody, and as you've seen some of the things we do here with the switching products that we make in the camera controllers and everything else. And with switching products, we have a piece of software that goes in between our hardware and a switcher because we need something to translate. So the one switcher we use is Ethernet based. So it could actually be directly communicated by these boxes. So I've been wanting to actually have it directly communicate from our boxes right to the switching device instead of going through the ATEM remote program that we use to do that. And I think I'm going to create the library. I have the library created in .NET, but I think I just need to translate it over to the Arduino. So I'm going to do a whole segment on creating libraries. So in the next couple of weeks, I plan on having that written as well. And I'll do a segment on creating libraries. So we have a bunch of things kind of planned up. I did talk to Bob while the segment was running, and he does not have the TV out ready for today. So he's going to keep working with it a little bit more, and maybe we'll have it ready for next week. If not, though, I got a segment for next week already kind of planned. It's already been recorded, actually. I recorded it right after I did the one we just watched. So but we got a lot of things coming up in that, and I have a couple other fun projects for myself for around the house and things I was working on as well. I want to do some shows around using like Android and Arduino together. So I have some projects I've been kind of playing with that. So there's a bunch of little things I have kind of in my queue, and I'm starting to line them up. And you see like this segment this week, and the quadcopter stuff starting to come in, so we'll do segments on that. And I'll probably record that as well, just because if I'm assembling it, I'm going to kind of fast forward through as well. I don't want to sit around and be completely bored watching me assemble a quadcopter, or maybe try to assemble a quadcopter, as the case may be. So I think it's good to record it, and then I'll fast forward through sections and stop and kind of comment like I did with this last one. This last one was a little bit longer than what I had planned on it being, and that's just the way it is. It takes a little while to go through and draw a schematic and explain it all out. I did check while the segment was running also. There is a free version of Eagle, but it's very limited. If you want the Eagle Lite version, it's $69. So that's like your, how do they describe it? Well, that's not a hobbyist. Hobbyist is something different. Eagle Lite allows you one schematic sheet, 2 signal layers, which is front and back, and a board size limited routing area of 100 by 80 millimeters. So, and the free version, let me see what it is. You can go far enough back. The free version limits, it's the same size board, limited 2 signal layers, 1 sheet. I don't know what the difference is then. It looks like the freeware and the $69 version are the same. The thing has to be different, but basically you can download Eagle and you should be able to open up the schematics. I'm going to put a couple more schematics, like I said, next week In there, we have some of our button boards. I'm going to throw a couple of those in there so you can kind of play with some things, move them around and buttons. One of our breakout boards for our Arduino, so you'll see an actual shield type of design as well. And then the one I just did, I'll put out there as well next week, in next week's show, in the show notes. This week, I will put out the PDF I just did, because I know it's kind of hard to see on the screen, but you can maybe kind of follow along if you print the PDF if you get lost in there. But if you're wanting to start design circuits and PCB boards, go download Eagle and try it. It's a great product. I cannot recommend it highly enough as a good product. All right, so Bob, like I said, Bob and I talked. Since he didn't really have anything, and he knew the segment was running, it was going to be kind of long, he decided to kind of skip out for this week, which is perfectly fine. Spend some time with his family, which is great. Next week, we'll be back at 9 p.m. on Monday night, and we will do the second part of this segment, and maybe Bob will have his TV out ready by then. And we'll see what else we can get in. Well, see what parts I come in and see what else I can work on next as well. I do appreciate you hanging in there through the long segment and telling your friends and spreading the word about us. We definitely appreciate all that. And we do have just a reminder, we do have a Google Plus community. There's been a lot of comments on the websites recently and also through email. But you might want to try the Google Plus community. If we get that built up, other people can help you out and make it more interactive, and you won't be waiting on me for a week to answer your email. So, unfortunately, that's part of life sometimes. All right, everybody. Thank you for hanging out on Monday night with us. We'll see you next Monday. For show notes for this show, contacts, and more, go to the TechZen.tv website, where you can get show notes for all of our shows. We love to hear from our viewers and listeners. We have an email, a Twitter, and a phone number where you can contact us for each show. For details, visit the TechZen.tv website and get the show details. You can also make a video and upload it somewhere like YouTube or Vimeo, and then just send us a link. You never know, you may see your video in a future show. You can get all of our shows delivered automatically to your favorite device by going to your favorite podcast website like iTunes and subscribing. Each of our shows also has a YouTube channel you can subscribe to get regular updates. Our shows are also available on most internet radio networks like Stitcher and TuneIn Radio. You can also watch and listen to our shows on Xbox, TiVo, and Roku. You can even find us on your Zune.